Hi friends, you are welcome to your favorite learning channel. This is Royal Learning Channel. My name is Oluwatoyin. In this video, we are going to discuss about 2025 WAEC Chemistry Practical. 2025 WAEC Chemistry Practical. As you know that this aspect is divided into three parts. The first part is on quantitative analysis, which is also known as volumetric analysis. Then the second part is on qualitative analysis, known as SWOT analysis, whereby you talk about test for cations, that is those are the positive ions. Then you test for anions, the negative ions. You talk about flame test and so on. Then the third aspect will be answered theoretically and it cannot be predicted. So in this video, I'm going to explain the first part, which is quantitative analysis. Then what are those things that we are going to discuss about under this quantitative analysis is how you can manipulate your table based on your teacher's title value without carrying out the experiment. Then ensure that you use your school title value, your teacher's title value, because your teacher's title value will be used to mark your own booklet. So how you can use your teacher's title value to form your own table without carrying out the experiment will be explained in this video. Then I will explain all the necessary rules and regulations that need to be followed to have your full mark. All the necessary rules and regulations that need to be followed to have your full mark will be explained in this video. Then we are going to solve two questions together, and I'm very sure that your question will not exceed what we are going to solve together in this video. So all you need to do is to follow this class till the end. Then if you are new here, click on the subscribe button to join this channel, or you DM me on +234 8128624004 +234 8128624004. So let's start with the first aspect, which is quantitative analysis. So when you check the top of your booklet of your question, the first thing you will see there is they will write all those stories. Then you see that record the volume of pipettes used. Record the volume of pipettes used. So the first thing you are going to do is to record the volume of your pipettes used. So check your pipette. Your pipette is in this form. Check the volume of pipettes that you are using in your school, or you ask your subject teacher that what is the volume of your pipette. So your pipette is in this form. So check the volume of that pipette. It can be written at this side or the upper part of the burette, but my own burette is 25 centimeter cube. Use your school burette. So the volume of my own burette is 25.00. Then your volume must be in 2 decimal places. Make sure that your volume is written in what? In 2 decimal places. So that is the first step. That is the first step to take. Now, I want to manipulate my table based on my own teacher's title value. So let's assume that my own teacher title value is 22.60 centimeter cube. That is the volume of acid used. The volume of acid used is 22.60 centimeter cube. Then don't forget that this table is for the volume of acid used. Then the volume of base is the same thing as what? The volume of your pipette used. So the volume of pipette used is the volume of your base. Now the volume of acid used will be the one that will be recorded in this table. Now my teacher's title value now is 22.60. Then I don't want to carry out the experiment. I want to form my table based on my teacher's title value. How will you do that? Then the first column, you write your burette reading. Your burette reading. Then in centimeter cube. In centimeter cube. If you fail to put this centimeter cube, that is your unit, -2 will be deducted from your mark. 2 will be deducted from your mark. Then burette reading followed by the first stage will be the final burette reading. Final burette reading. Then your final burette reading in centimeter cube, then followed by initial birth reading. Initial birth reading in centimeter cube. Your unit in centimeter cube, very important. Then the last stage is volume of acid used. Volume of acid. A is your acid. Volume of acid used. Then your volume of acid used in what? In centimeter cube. Don't forget, volume of acid used in centimeter cube. Then I want to form my table now based on my what? On my teacher's title value. Then on your table you must have at least two concordant value. Two concordant value. Then what do I mean by two concordant value? So your concordant value must not exceed plus or minus 0.1. That is maybe the first title value, the second title value. So the first title value and the second title value. So the difference between the first title value and the second title value must not exceed plus or minus 0.1. 0.1. So the first column is for rough titration. The first column is for rough titer. Then the second column is for first titer. First titer. Then second titer. Second titer. Then your rough titer, now you now work on this your teacher's titer value now. I want to use my teacher's titer value to form this table. So I can use my exact teacher titer value under the rough titer. Then what is the function of rough titer? Rough titer will guide you to have an accurate what? Accurate result in the subsequent titration. Rough titer value will guide you to have an accurate result in the subsequent titration. Now, let me start with my teacher's titer value. My teacher's titer value is 22.60. 22.60. Then what will be my initial birth reading? What will be my initial birth reading? Your birth is in this form. Your birth is in this form. You see something in form of tap down. So the upper part of your birth, you see 0.00 there. So that is the starting point of your birth, which is your initial reading. So my initial reading will be 0.00. Then make sure your values that will be recorded in this table are in 2 decimal places. Very important. Your values that must be recorded in this video must be in 2 decimal places. If you convert it to 1 decimal, if you round it up to a whole number, it's minus 2. 2 will be deducted from your mark. Then if you approximate it to 1 decimal place, there will be deduction of what? Of 2 marks from your result. From your mark. 2 marks will be deducted from your mark. So make sure that your table, all your values are in what? In 2 decimal places. In 2 decimal places. Now I want to form the first titer now. Don't forget that I'm working on this my teacher's titer value. Then I've started the first part, which is my rough titer value with my teacher's titer value. Now the first titer now, first titer, then I will minus 0.5 from minus 0.1 from my teacher's titer value. So deduct 0.1 from 22.60 will give me 25.60. So my first titer now will be 22.50. 22.50. So my initial titer value will still remain as 0.00. 0.00. Then the second titer value, or let this one be 22.70. Let me start with plus 0.1. Let me start with plus 0.1. So this 22.60 plus 0.1 will give me what? 22.70. Then the next one, I will use my teacher's title value again, exact my teacher's title value. That will be 22.60 because I don't want to go far. I don't want to go far from my what? Teacher's title value. Then my first title value and second title value must be concordant. It must be concordant. So the difference between the first title value and the second title value must not exceed 0.1. The difference between my first title value, because the rough title value will not be included in the calculation. The rough title value will not be included in the calculation. So I need my first title and the second title. So the concordant value of the first title and the second title, that is the difference between the first title value and the second title value, must not exceed what? Is 0.1. It must not exceed 0.1. So 22.70 and 22.60, we have difference of what? Is 0.1, which is okay. But if this one, if your first title, let's assume that your first title is 22.70 and the second title is now around 22.50. So 22.50 to 22.70, that will be difference of what? Is 0.2. Is 0.2. So your title value, that is your title value, exceed is 0.1. 1 will be deducted from your mark. So now I have my concordant title value now. So the difference between this first title value and second title value is what? Is 0.1. So which is okay. So my initial reading for the second title value will still remain as 0.00. Then you subtract the initial reading from the final reading. So 0.00 minus 22.60 will give me 22.60. Then 22.70 minus 0.00 will give me 22.70. 22.60 minus 0.00 will give me 22.60. So the next stage after your table is to calculate the average volume of acid used. So you use your concordant title value to calculate the average volume of acid used. No, average volume of acid used, then will then be equal to, so we don't use what? Rough title value in calculation. So you use your first and second title value. So my first title value is 22.7 plus the second title value is 22.60. So 22.70 plus 22.60, 22.70 plus 22.60, then divided by how many? We use 2 concordant title values, so that's divided by 2. So 22.70 plus 22.60 divided by 2 will give us 22.65 centimeter cube. Then don't forget that your volume must be in 2 decimal places. Ensure that your volume is in 2 decimal places. Then don't forget to write the volume of your pipettes used. The volume of pipettes used. This one will carry 2 marks. The volume of your pipettes used. Then the average volume of acid units. Don't forget to write your unit in what? In centimeter cube. In centimeter. So that is how to manipulate table without carrying out the experiment. That's how to manipulate table without carrying out the experiment. So after your table and the average volume of acid used, then you can now go back to your questions. So we are going to solve these questions together. So before we work on these first questions, I'm going to explain terms on quantitative analysis. Terms that you need to know about quantitative analysis. So what are those terms that you need to know The first one is molar concentration. Molar concentration. Please don't write conc, write it fully. Molar concentration. So molar concentration is always in mole per dm cube. That is the unit, mole per dm cube. So when you see a value in mole per dm cube, they are talking about the molar concentration. When you see a value in mole per dm cube, they are talking about the molar concentration. So it can either be the molar concentration of acid or the molar concentration of base. So that will be stated in your question. If it is the molar concentration of acid, it will be stated in your question. Then if it is the molar concentration of base, it will be stated in your question. So let's take for example 0.200 mole per dm cube. So when you see something like this, they are talking about what? The molar concentration. Then another one is mass concentration. Mass concentration. So mass concentration is always in gram per dm cube. Gram per dm cube. So when you see a value in gram per dm cube, when you see any value in gram per dm cube, it is the what? Mass concentration. So it can either be the mass concentration of acid or the mass concentration of base. So mass concentration is always in what? In gram per dm cube. Then when you solve any question on mass concentration, your unit must be in gram per dm cube. So failure to add unit, to write unit, we award no mark. No mark for no unit. No mark for no unit. Then another one is molar mass. Molar mass. So our molar mass is always in gram per mole. In gram per mole. So molar mass is in gram per mole. Is in gram per mole. Then another one is the number of mole. Number of mole or amount. Amount is in mole. So when you see a value in mole, they are talking about amount of a substance. Amount of a substance. So let's talk about formulas. Different formulas that we can use to solve questions on quantitative analysis. So what are those formulas that we can use to solve questions on quantitative analysis? So we have one called the general formula. The general formula, which is CA VA over CB VB is equal to NA over NB. So this is the general formula. C means molar concentration. C means molar concentration. Then, if you now see Ca, A is acid. So that will be the molar concentration of acid. So while Cb will be the molar concentration of base. Then V is the volume. So volume of what? Volume of acid. While Vb will be the volume of base. N is the number of mole of acid. So you derive your number of mole of acid from equation of the reaction. N is the number of mole of acid. So according to this equation, our acid is HCl. So the number of mole is the coefficient of this HCl. The coefficient of this HCl is the number of mole. Then Nb is the number of mole of base. Nb is the number of mole of base. Then our base is what? XHCO3. So it will be stated in your question. When you read it, you know that XHCO3 is your base, while HCl, then as you know that hydrochloric acid is an acid. So this is our acid. So another formula is molar concentration Another formula is molar concentration molar concentration. Then the unit for molar concentration is mole per dm cube is equal to mass concentration. Then unit for mass concentration is gram per dm cube. Don't forget to write their units divided by the molar mass. Divided by the molar mass in gram per what? Gram per mole. In gram per mole. So this is another formula. So you can use this formula to look for molar concentration when mass concentration in gram per dm cube and the molar mass of the substance is given. Then you can calculate the molar mass of the substance from the chemical formula of that substance. If the substance does not contain an unknown value, if it does not contain an unknown value. So you can use this formula to look for molar concentration. You can use it to look for mass concentration. Then you can use it to look for molar mass. Then the general formula, that is dCAVA over CBVB equal to Na over Nb. You can only use this one to look for what? Either the molar concentration of acid or the molar concentration of base. So we always use it to look for the molar concentration of either acid or that of base. Then another formula is amount. Then amount in mole. Amount in mole. To calculate amount in mole, you use molar concentration, then times volume, the volume of that substance in dm cube. Molar concentration multiplied by the volume of that substance in dm cube. So those are the common formulas that we can use under volumetric or quantitative analysis. Then the other aspects, you use mole concept. We always use mole concept to solve the other aspects. Then I want to explain something on this table. If you cancel your table, let's assume that you have prepared your table already. You have prepared your table. You have prepared your table and you discovered that you have made a mistake. You have prepared your table, then you have discovered that you have made a mistake. Then you now cancel. Cancellation. Cancellation is -4. -4. 4 marks will be deducted from your table. So make sure that you calm down to form your table. Form your table diligently. So cancellation is -4. -4. While alteration on the table, maybe you have written 22.60 now, then you made a mistake, you want to alter it, you now cancel like this. Then to write what? The correct value under. This one will what? They will deduct 2 marks. It's -2. Alteration of table is -2. Alteration of table is -2. While cancellation of table is -5. Is -5. So let's continue. Now let's come back to these questions. So A is a solution. A is a solution containing 0.015 mole per dm cube HCl. Anything mole per dm cube is what? The molar concentration. So it means that 0.105 mole per dm cube is the molar concentration of acid. Our acid is HCl. Then for this year, our titration is on NaHCO3 plus HCl. So the titration for this year is on sodium hydrogen and hydrochloric acid. So it shows that our titration for this year is acid-base titration. This is our base, while HCl is what? Is our acid. So this year practical is on acid base titration, is acid base titration. Now let's come back to the question now. A is a solution containing 0.10 mole per dm cube HCl. So anything mole per dm cube is the molar concentration. Then the molar concentration of what? Of HCl. The molar concentration of acid. Then the molar concentration is the same thing as C. C is the molar concentration. Then acid, that is A. Ca is the molar concentration of acid. So what's the molar concentration of acid now? That is 0.105 mole per dm cube. Mole per dm cube. Then let's read further. B contains 6 grams of impure baking powder SHCO3. So it shows that an impure substance is added to SHCO3, but our SHCO3 is our real what? Is our real sample, is our real base, but something has been added to it, which is an impure. So B contains 6 grams of impure. So it shows that this 6 grams of is the mass concentration of what? Of that impure substance that we don't know. Is the mass concentration of that impure substance that we don't know. So 6 grams of impure baking powder HCl per 250 centimeter cube. So our mass concentration should be in what? In gram per dm cube. But this one is gram per 250 centimeter cube. So you are going to record this mass of impure equal to 6 grams per 250 centimeter cube. Is 6 grams per 250 centimeter cube. So you have to convert this 6 grams per 250 centimeter cube to gram per dm cube, because our mass concentration must be in gram per dm cube. Either mass concentration of pure or the mass concentration of an impure. It must be in gram per dm cube. So we have to convert it to gram per dm cube. So to convert this 6 grams per 250 centimeter cube to gram per dm cube, that would be, then don't forget that 1 dm cube, I want to convert it to dm cube. 1 dm cube is equivalent to 1000 centimeter cube. 1 dm cube is equivalent to 1000 centimeter cube. So I want to convert it to 1 dm cube, which is the same thing as 1000 centimeter cube. So that would be 6 times 1000. This 6 grams times 1000 divided by 250. So 250 here 1, 250 here 4. 6 times 4 will give me 24. So I've converted it to dm cube now. It should now be gram per dm cube. Then we should not forget that this 24 gram per dm cube is the mass of what? Of an impure substance. Is the mass of an impure. Then we don't use mass of an impure to look for molar concentration. Don't use mass of an impure to calculate the molar concentration of that substance. So you can only use it to calculate the percentage purity or the percentage impurity. You can use it to calculate percentage purity and the percentage impurity. So we have converted this 6 grams per 250 centimeter cube down to what? To gram per dm cube, which is equal to 24 grams per dm cube. So let's read further. Now put A into the burette, which you have done, and titrate it against 20 or 25 centimeter cube portion of B. So that is the volume of your what? Of your pipette. If the volume of your school pipette is 20, you write 20 here. Then if the volume of your school pipette is 25, you write 25 here. So my volume of pipette is 25. Then the volume of your pipette is the same thing as the volume of your base. Your volume of pipette is equivalent to the volume of base. Then V is the volume. So my volume of base is equal to my volume of pipette, which is 25.006 centimeter cube. 25.00 centimeter cube. Then let's read further. Repeat the experiment to obtain a consistent titer. So this is our consistent titer value. We have done that. Tabulate your results and calculate the average volume of acid used. Without telling us, we have done it already. So we have tabulated our results. Then we've calculated the volume of acid used. So the volume of acid used is 22.65. Then the volume of acid used, volume of acid, is equal to this 22.65 centimeter cube. So you write all your parameters out, write all your values out from the questions. So before you start solving, now from your results and information provided above, calculate the, so from all these results and the information provided, then calculate the Roman figure 1. Roman figure 1, I want to clean the information off. So from your results and the information provided, then question 1 says, calculate the concentration of XHCO3. Then what is my XHCO3? That is my base. Since this is my acid, HCl is my acid, so automatically XHCO3 is my base. So X is now an unknown. It's an unknown in this what? In this chemical formula. So calculate the concentration of XHCO3 in mole per dm cube. In mole per dm cube. So XHCO3 is my base. Is my base. Anything mole per dm cube is concentration. Anything mole per dm cube is concentration. So it shows that I'm looking for concentration of base. Concentration of base, which is Cb. So my Cb is unknown. C means concentration, B means base. So I'm looking for concentration of base. So concentration is in mole per dm cube. Then which formula can we use to look for the molar concentration of base? Which formula can we use to look for the molar concentration of base? So let's try our general formula. Maybe it will work. Ca Va over Cb Vb is equal to Na over Nb. Is equal to Na over Nb. Then I'm looking for Cb. This is my unknown. Then Ca, my Ca is what? Is 0.105. Then Va, that is the volume of acid used. Your average volume of acid used is your what? Your Va. So my Va is 22.65. Then I'm looking for Cb. Then my Vb is the volume of my pipettes used, which is 25.00, which is 25.00. Then Na, so your Na is the number of mole of acid. The number of mole of acid. So you go back to the equation of the reaction. My acid, this is my acid. Hydrochloric acid is my acid. So what is the coefficient of this acid? The coefficient is 1. So therefore, my Na is equal to 1. Then Nb is the coefficient of base. Nb is the coefficient of base. So this is my base. What is the coefficient of base? It is 1. The coefficient of my base is 1. So my Nb equal to 1. So we can apply this formula now to look for what? For my Cb. I'm looking for Cb. So the next step now, after this general formula, is to make what? Your Cb the subject of the formula. You make your known the subject of the formula. That is 1 mark. So failure to write down next step we what? You are going to miss 1 mark for that if you don't write the next step by making the what? Your known the subject of the formula. So make CB the subject of the formula, you cross multiply. So I'm looking for CB. So it will give me CB will be equal to CAVA, then MB divided by VBNA. So CB will now be equal to, so you can put all your parameters now. So what is my CA? My CA is 0.105. So 0.105 multiplied by VA. My VA is 22.65. Then my NB is equal to 1. Then divided by my VB. My VB is the volume of pipettes used. Which is 25.00. So that's 25.00 times my NA is the number of mole of acid. That is 1. So by the time you multiply everything together, and you divide by 25.00, you are going to arrive at 0.095. Then anything molar concentration, C is your molar concentration. Anything molar concentration must be in what? In mole per dm cube. If you don't put your unit, there will be no mark for the final stage. No mark for no unit. Then we have solved the first question. So let's move to Roman figure 2, question number 2. Then you make sure that your molar concentration, please, your molar concentration is in what? Is in 3 significant figure. Make sure that your molar concentration is in 3 significant figure. If you have more than 3 significant figure from your calculation, so ensure that it is in 3 significant figure. So let's move to Roman figure 2. So we are looking for amount of HHCO3. We are looking for the amounts of hydrogen triisocarbonate 4 compound. We are looking for the amounts. Then what is the formula for calculating amounts? Amount in mole, the unit is in mole, is equal to molar concentration times volume in what? In dm cube. Molar concentration times volume in dm cube. Then we have gotten the molar concentration of base now, which is our CB. Our CB is equal to what? 0.095 mole per what? Per dm cube. That is the molar concentration of base. Then we are looking for the amount of XHCO3. So XHCO3 is my base. Hydrogen triisocarbonate 4 compound is my base. So I'm looking for the what? The amount of my base in what? In 250 centimeter cube. In 250 centimeter cube. So, and the formula for calculating amount is what? The molar concentration. So the molar concentration of what? Of base that I'm looking for. Then the molar concentration of base is CB. So which is 0.095. So molar concentration is now what? Is 0.095. Then times the volume of what? Volume in dm cube. So they've given us volume from this question. Amount of my base in 250 centimeter cube, but your volume must be converted to what? To dm cube. Your volume must be converted to dm cube, but the volume here is 250 centimeter cube, so that will be 250 divided by 1000. Why? Because 1 dm cube is equal to what? 1000 centimeter cube. Is equal to 1000. So I've converted this one to dm cube now, from 250 centimeter cube to 1 dm cube. So what will be our answer for that? So that's 0.095 times 250 divided by 1000 will give us 0.023475. 0.02342375. 0.02375. What is the unit in mole? Your unit is very important. Your unit is very important. So that is the amount or the number of mole. Amount is the same thing as the number of mole. So let's move to the next question. So the next one says that calculate the volume of CO2 produced from 250 centimeter cube of the solution B at STP. Calculate the volume of CO2 produced from 250 centimeter cube of what? Of solution B at STP. At STP. So to calculate the volume, you go back to your question. So they said the volume of CO2 produced from solution B. This is your B. This is your B. This is your base. So the volume of CO2 produced by this base is this. So it produces what? 1 mole of CO2. So it produces 1 mole of CO2. So you first write the number of mole of your base and the number of mole of CO2 produced from your base out first. So your base, which is XHCO3. So 1 mole, the coefficient of your base is 1. So you say 1 mole of XHCO3 produces what? How many mole of CO2? 1 mole of CO2. Then don't forget that 1 mole of any gas at STP is 22.4 dm cube, is constant. 1 mole of any gas at STP, because it says that the solution of B at STP. So 1 mole of any gas at STP is equal to 22.4 dm cube. So you are going to rewrite it now. Now 1 mole of XHCO3 will now be equal to the 1 mole of CO2. CO2 is a form of gas. So the 1 mole of CO2 gas is what? 22.4 dm cube. So this 1 mole will now be equivalent to 22.4 dm cube of what? Of CO2. Of CO2. Then we go back to the number of mole. So what is the new number of mole form? So we need the number of mole now. So to calculate the number of mole, don't forget that the number of mole is the same thing as what? Amount. The new number of mole is the same thing as amount, which we have done now. So the number of mole is equal to molar concentration. So we don't need to go back to that since we have done it before. But if your question did not ask you to calculate the number of mole before this kind of question, so you have to calculate the number of mole first. You have to calculate the number of mole. Now, we need the new number of mole of XHCO3, because they said, so the number of mole produced in 250 centimeter cube. So you have to calculate the number of mole in 250 centimeter cube, which is molar concentration times volume in dm cube. Then we have done it now. We have done it. So the molar concentration is equal to, so the molar concentration of what? Of base. The molar concentration of base, which is 0.095. is 0.095 times the volume in dm cube. So the volume produced in 250, volume of CO2 produced in 250, that is 250. Then you want to convert it to 1 dm cube divided by 1000. So our answer is equal to 0.02375 mole. So you now bring this number of mole down here. You bring it down here. So you now say that is 0.02375 mole of XHCO3. Then we produce X what? XDN cube. XDN cube of CO2. So we are looking for the volume of CO2 that will be equivalent to this number of mole. The first number of mole is derived from the what? From the chemical reaction. The first number of mole is generated from this chemical reaction. That is 1 mole. So we have to look for the number of the volume of what? Of CO2 that will produce by this what? By our new number of mole. Now then you cross multiply. So x, unknown x, times 1 will give us x. XDN cube of CO2 will now be equal to the new number of mole, which is 0.02375 times, so the volume 22.4 dm cube. So our answer will now be equal to, the final answer will be equal to 0.532 dm cube of what? Of CO2. Is 0.53 dm cube of CO2. Then the next one is the percentage by mass of hydrogen thiazocarbonate in the sample. Don't forget that the sample consists of an impure substance, but we don't know that impure substance. Then our XHCO3 is pure. Our XHCO3 is pure because it is our real base. Our real base is pure, but it contains an impure substance according to the question. So it contains an impure. So mass of impure is this 6 gram per 250 centimeter cube that we have converted to 24 gram per dm cube. So we are looking for the mass percentage by mass of XHCO3. So XHCO3 is our pure substance because it is our base. So we are looking for the percentage by mass of pure base, which is XHCO3. Now, to calculate the percentage by mass of XHCO3, you have to look for the mass concentration of what? Of XHCO3, because our mass here is mass of an impure. It's mass of an impure content of what? Of XHCO3. So we have to look for the mass of pure XHCO3. So to look for mass of pure XHCO3 now, we are going to use formula molar concentration. Don't forget that I told you that you use this formula to look for molar concentration, mass concentration, and molar mass. So molar concentration is equal to mass concentration divided by the molar mass. So I'm looking for the mass of impure, mass of pure, because this is our pure substance. So which is the same thing as mass concentration. So you make mass concentration the subject of the formula. So you now say mass concentration of XHCO3 is equal to mass concentration of XHCO3. When you make mass concentration the subject of the formula, will give us molar concentration times molar mass equal to molar concentration multiplied by molar mass. So which is equal to, then what is the molar concentration of XHCO3? That is our base. The molar concentration of base is 0.095. So that will be 0.095 times the molar mass. So they've given us the molar mass of XHCO3, which is 84 gram per mole. Don't forget that our molar mass is always in gram per mole. So the molar mass of XHCO3 is what? Is 84 gram per mole. So times 84 times 84. So it's 0.095 times 84. 0.095 times 84 will give us 7.98. It will give us 7.98 gram per dm cube, because we are looking for the mass concentration. That is not where we are going, but we are looking for the what? The percentage by mass of XHCO3 in the sample, because the sample consists of what? Of impure substance. So the final answer now, so the percentage by mass of XHCO3 will now be the mass of pure. So this is our mass of pure. Mass of pure. So it should be the mass of pure equal to mass of pure divided by the mass of an impure. Mass of impure times 100 equal to, so the mass of pure is the mass concentration of our base, which is 7.98. So 7.98 divided by the mass of impure. So this is our mass of impure. Our mass of impure is 24 gram per dm cube. 24 gram per dm. So we have converted this 6 gram per 250 centimeter cube to 24 gram per dm cube. So divided by 24 times 100. So equal to, so the final answer is, so that will be 7.98 times 100 divided by 24 will give us 33.25%. Since we are looking for percentage, it must be in percent. It must be in percent. So that is that about Roman figure 4. So let's move to Roman figure 5. Let's move to Roman figure 5. Let's move to Roman figure 5. Roman figure 5 says that calculate the value of X in XHCO3. I'm looking for the value of X in XHCO3. So value of X in XHCO3. So to get the value of X inside this XHCO3, that will be XHCO3 equal to the molar mass. So the molar mass of this compound, so XHCO3 is equal to the molar mass of this compound. Then they've given us what? They've given us the molar mass of this compound, which is 84 gram. So you are now going to say XHCO3 is equal to 84, which is the molar mass of the whole compound. So the molar mass of the whole compound is 84. Now, add the atomic mass of each of the four of the elements that are present here together. Add their mass number together. So X is unknown. I'm looking for X, plus the atomic mass of hydrogen is 1, plus the atomic mass of carbon is 12. Then plus the atomic mass of oxygen is 16. But we have how many oxygen atoms? So 3 atoms of oxygen. That will be 16 times 3 equal to 84. Equal to 84. So x plus, so 12 plus, so that will be x plus 1 plus 12 plus 16 times 3 will give me 48 equal to 84. So 1 plus 12 will give me 13. 13 plus 48 will give me 61. So 1 plus 12, that's 13. So 13 plus 48 will give me 61. So x plus 61 equal to 48. So x will now be equal to 48. Bring 61 here minus 61. So 48 minus 61 will give me what? So this one will give me 7. This one will give me 7. So 4. Sorry, 84. This 84. This is 84. So our molar mass is 84. So that will be 84 minus 61. So this one will give me 3. 8 minus 6 will give me 2. So equal to 23. So the mass of x is equal to, mass of x is 23. The molar mass of x is 23. So make sure you follow all the necessary rules and regulations. Don't cancel your table. Don't cancel your table. Cancellation of table is -4. It's -4. Then failure to put your unit is -2. -2. Then ensure that your table, that is your BRES reading, is in 2 decimal places. All your values must be in 2 decimal places. Then don't forget to write the volume of your pipette used. The first thing is to write the volume of your pipette used in what? In centimeter cube. Don't forget to write the volume of your pipette used. Then ensure that you put the accurate units. Put accurate units. Your molar concentration must be in 3 significant figure. Your molar concentration must be in 3 significant figures. So if your figure is more than 3 significant figure, ensure that you convert it to 3 significant figure. Let's take for example, my answer in my calculator is 0.095 to 0.09510. So my molar concentration will be what? Is 0.095. You can leave it like this, or 0.0951, but it's okay like this. So make sure that your molar concentration is what? Is in 3 significant or 2 significant figures. In 2 significant, then it must be in mole per dm cube. Anything molar concentration must be in mole per dm cube. Don't forget, your molar concentration must be in mole per dm cube. Your mass concentration must be in what? In gram per dm cube. It must be in gram per dm cube. Then your molar mass must be in gram per mole. Your molar mass must be in gram per mole. So follow all the necessary rules and regulation. Thank you. See you in my next video.